Welcome, everyone, to the first session of the IT Professionals Conference and for day 2 of our virtual day. So our first session of the morning is static web hosting in AWS with OpenID Connect. And I will turn it over to Ben to introduce himself. And let's get the day rolling right. Thanks.
Hi, everyone. My name is Ben, and I'm a member of the road team within Do It. I've been working here at the university for almost a year now, and mostly been working on some services like DARS and Course Search and Enroll. So that's kind of a brief rundown on me. I suppose we can start up this presentation, right? Okay. So let's get started. In this presentation, we're going to be discussing a strategy for hosting static websites in AWS that require user logins federated by NetID Login Service. First, let's talk about the main big question. Why? Why do we need an alternative to Apache? Why should we put in the effort to migrate to an AWS-native solution? Well, let's first start out with the deployment pipelines. The deployment pipelines for containerized Apache clusters in AWS are difficult to maintain due to the complex configuration that comes with them. Another note is that if it's your first time setting up infrastructure like this, it can be a challenge to configure the Apache instances for the first time. Standardizing the deployment pipeline keeps the developer experience, or DX, consistent between projects. For us, we use GitLab for our deployment pipelines, and having everything the same, standardized across all projects, helps keep it consistent so that we can easily onboard new developers and other team members to new projects. Along with this, we also use Terraform to deploy our infrastructure to AWS. So keeping that consistent and using AWS native solutions allows us to use Terraform to bring up that infrastructure in a predictable manner. Next, we have sticky sessions. Sticky sessions must be enabled on the application load balancer in order to keep users logged in. The reason for this is because when a user signs in to your website, it'll assign them to a single Apache instance for the duration of their session. This is just how Shibboleth works under the hood if you don't have something like Memcache running on the back end to share the sessions between the Apache instances. And what this means is that if an Apache instance goes down, your users that are logged in to that specific instance will be logged out, and they will have to re-log in again by refreshing the page, losing any progress they may have. Lastly, if you want to serve website files from an S3 bucket or something similar, which the main point of this is to keep your website and web server deployment separate, you must proxy request to the S3 bucket's static website instead of incorporating the website files into your Apache configuration deployment. That's another kind of challenge that Apache comes with, which can make it a bit more difficult to work with. So here's an example diagram showing how a web server and website may be deployed in AWS if you're using Apache and Shibboleth. You'll immediately notice that there's quite a bit of architectural complexity just to host the web server itself in the cloud. So let's kind of walk through what we're looking at here. Let's say a user visits your website. Let's say like enroll.wis.edu for course search. First, it'll resolve that domain so that they know where to route the user. That's the DNS resolution part. After that, the user's request will be routed through to the application load balancer. And this is where sticky sessions get enabled. So at this point, it'll check if the user has the session ID cookie in their cookies. If it does, it'll try and route that user to the same Apache instance. Otherwise, it'll use whatever algorithm the load balancer uses to route it to a new Apache instance. So after that gets decided, it'll go through the NAT gateway and into Elastic Container Service, which is where our Apache cluster is being hosted. And in this cluster, there will be individual EC2 instances that auto-scale depending on load. Now these instances, they get their configurations from Amazon EBS, or Elastic Block Store. And these EBS volumes get mounted onto the EC2 instance so that we can access the Apache and Shibboleth configurations that way. Once the configuration is in the EC2 instance, it'll then determine what route the user is trying to go to, and if it's trying to access the static site files, it'll proxy the request to the Amazon S3 bucket, and at that point, it will be returned all the way back to the user. So this is something that can definitely be improved on. I mean, do we really need to set up all this infrastructure when the main goal is to just deliver files from a bucket, which should sit behind NetID login? Now, yes, we do need to handle large loads, hence the application load balancer and the auto scaling, but it can still be better. Before looking for an alternative solution, we need to step back and think about what we even need. First, we need federated login through NetID Login Service. This allows us to determine who our users are and allows us to only show parts of the application that each specific user is authorized to view. Another big necessity is we need our website to have zero downtime and high scalability. When users visit your site, they're kind of expecting it to just work in a reasonable amount of time, right? Now, easier said than done, but as site administrators, we should do whatever we can to accomplish that goal to keep our users happy. Next is predictable and reliable deployments. If you're deploying out of a GitLab or GitHub CI/CD pipeline, how do you know it's going to deploy correctly when you click on the deploy button? What's going to happen if it fails? These are all important questions that you need to be prepared for so you can have a backup plan if something does go wrong during deployment. Additionally, we need to have a method to access protected backend services. Majority of websites will need to have some sort of data coming into the application, and will also need to take action depending on what the user does. Without access to those backend services, how much value would your website provide if it's not purely informational? That's why it's important to have that connecting piece to access those services. Finally, from a developer experience standpoint, it would help out tremendously if we could separate the web server and website deployment pipelines. Whenever you wanted to make a change to your website, why should you need to redeploy the entire web server for those changes to take effect? That seems unnecessary, and while this is more of a want than a need, it allows you to deploy site changes quickly into web servers that are already running. This also reduces the risk of outages during deployment, as the web server is a piece that's accepting client connections in the first place. So how do we accomplish these goals? One solution for that problem is OpenID Connect. So, what is OpenID Connect? For starters, it's an extension of the OAuth 2.0 standard that adds an additional identity layer to it. For websites that are transactional, we need to know who our users are. OpenID Connect provides us with a who, and does so in a way that we can extend those identities to our backend services. It gives applications the ability to verify an end user, the who, based on the authentication performed by an authorization server. An example of an authorization server in this case would be NetID Login Service and GitLab 2 for CI/CD pipeline identities. The applications that can verify these identities include any backend services you provide support for, and even AWS works with OpenID Connect to provide parts to the AWS SDK by assuming a role with the identity token. Any place where you need to verify who is making the request can be done with OpenID Connect. So how can OpenID Connect help? First, it takes the place of Shibboleth, which removes the need for any SAML or security assertion markup language. We don't need to specify any more XML configurations, as OpenID Connect works purely off of query parameters and JSON for the responses. Second, it integrates nicely with Manifest to provide user groups via a JWT claim or JSON Web Token claim. In Manifest, we can specify our application's OpenID Connect client ID inside of any group in Manifest that we administer, and it will populate the JWT claim with all the groups in Manifest that have our application's client ID associated with it. kind of like how Shibboleth works. This JWT claim sits alongside the rest of the user information, like their email, NetID, name, and more. So it's all in one convenient place. One big part of OpenID Connect in AWS is that we can handle the entire login flow ourselves for maximum control and predictability. Now, while this may sound like a downside because you have to handle the flow yourself, I'd argue that the benefits outweigh the drawbacks because you can control every piece of the flow, every status code and redirect, every error that occurs, and any error pages that should display as a result. This makes it much more predictable because not only can you write the code for it, but this means you can unit test it so you'll have much more confidence when the code gets deployed in a production setting. Having to write a few hundred lines of code is well worth it, in my opinion, for the kind of control you get out of it. Now let's talk about how your website will get distributed to your users. For website distribution, we use AWS CloudFront. CloudFront regionally distributes your website all across the United States and is highly scalable and available. As defined in the CloudFront SLA, or Service Level Agreement, you can expect more than 99.9% uptime, or you'll be refunded service credits in AWS. One other nice feature of CloudFront is that you have pay-as-you-go pricing. What this means is that with pay-as-you-go pricing, you don't have to pay if you're not receiving any requests to your distribution. So if you have any extra tiers, like development tiers, test tiers for quality assurance, if there's no traffic going to those tiers, then why should you have to pay for them to sit idle? That is where CloudFront is useful because it's just pay as you go. You pay for the requests that come in, and you pay for the Lambda executions and whatnot. Additionally, CloudFront supports S3, ELB, or Elastic Load Balancing, and API Gateway Origins. This allows you to route all requests to an S3 bucket for static website files, and then you can route specific paths to an API via the ELB or API Gateway Origins. This is nice because you can target backend services natively in CloudFront without using a custom Lambda to implement that behavior. So how does your infrastructure get deployed? Well, for this, we typically use Terraform for that. All relevant AWS services, including CloudFront, S3, Lambda, and any other related services can be deployed using Terraform. This is nice because you can verify infrastructure changes by using plan jobs inside of merge requests before deploying. So if you've seen this image below, we have a plan dev job. What it will do is it will tell us exactly what infrastructure changes will take place if we click on the deploy dev button. It's very neat in that sense, as it gives us a detailed report on exactly what will change every parameter of each service specified in our configuration. Lastly, there's zero downtime, as there will always be CloudFront nodes available, even during deployment. CloudFront deployments take time, now usually only a couple minutes because they're regionally distributed, and so it needs time to replace all of those individual nodes. And as it's doing that, the old nodes will still be available as new nodes are being brought up using the new configuration. It's kind of like a rolling deployment in the sense that there will always be nodes available while a deployment is taking place. So how do we handle user authentication if we're taking Shibboleth out of the picture? Well, with OpenID Connect, we can use AWS Lambda Edge to do this. Lambda Edge is a feature of CloudFront, and it uses Lambda at its core. But the @edge part is because you can deploy those Lambdas regionally with CloudFront. Kind of like how CloudFront gets regionally distributed across the United States. The Lambda functions also go along with it. With Lambda Edge, we have full control over the OAuth 2.0 flow that users will go through to log into your website. What this also means is that you can redirect users to log in before ever reaching sensitive website assets. If you go to the homepage of your application and you see that it's just blank because the user's session has expired, this prevents that, as it will catch it on the spot and it'll just redirect using a 302 status code to the NetID Login Service instead of just returning a blank page. So it's nice that you have that middleman to handle those expired sessions. And that comes with the full control that you have over the OAuth 2.0 flow as well, because the Lambda gets invoked on every single request to CloudFront. So it's able to check for all those things before ever returning your website assets. Lastly, the Lambda will deliver a verifiable identity token JWT or JSON Web Token, which can be used in backend services. Well, not just backend services, it's also used to keep your session open in CloudFront, so it will keep returning the website assets without going through the entire login flow again. But this JWT can be sent along to backend services as well, so that they can verify the users that are making API calls. So let's walk through this diagram that we have at the bottom of this slide. This diagram describes what a user would expect to happen if they visit your website for the first time and they haven't been logged in yet. So first, let's say they go to your home page. It's at step 1, the initial GET request for index.html. After they get routed to your CloudFront distribution, CloudFront will invoke the Lambda at step 2 at the viewer request hook. Viewer request is one of the parts of the request lifecycle that you can hook Lambdas into. So there's a viewer request, origin response, and viewer response. So viewer request is just that first hook that you can hook a Lambda into in the request lifecycle. So after CloudFront invokes your Lambda, the Lambda will check the cookies that the client sent over. If the identity token is not in the cookie, then it knows that the user is logged out. And so we need to redirect them to NetID Login Service to log in. To do this, it'll return a 302 to the client and have them redirect to NetID Login Service's OIDC authorized endpoint. Once this is done, the user will be at the NetID login page to type in their NetID, their password, and do any dual pushes that they need. So that all happens between steps 3 and 4. After they're done with that entire flow, the user will be redirected back to our application in step 4, which is a 302 redirect to the OAuth 2 IDP response endpoint. Now you can name this whatever you want, but we haven't named OAuth 2 IDP response because it has the OAuth 2 for that's the flow that we're going through, and then IDP response for the identity provider response. So that's why it's named this way, but you can name it whatever you want. So after this, we'll be back at the CloudFront distribution. CloudFront, as it always will invoke the Lambda as it's part of the viewer request part of the request lifecycle. And this Lambda will see that we're at the OAuth 2 IDP response URL, which means we just returned from logging in. And along with that URL, it also comes with an authorization code in step 4 that NetID Login Service gives us. So with that URL and that authorization code, the Lambda will make a post request, which is just another type of HTTP request to NetID Login Service at the OIDC token endpoint. It'll say it's passing along an authorization code, and it will also pass in the authorization code along with it. NetID Login Service will then check that code, and as a result, if it's successful, it will return the standard access token, ID token, refresh token if you have that enabled, and the expiration date. Once those get returned to the Lambda will then return that to the user and have the user set it in their cookies using the set cookie header. Only ID token is listed here, but if you have the refresh token, that can go along with it too. And refresh capabilities will need to be implemented in the Lambda as well. So at this point, it'll be returned to CloudFront, and in between step 7 and 8, CloudFront will pull your website files from S3, and it will then return it back to the client. So that kind of outlines the entire login flow of all the pieces that a user can expect to go through when visiting your site and they don't currently have a session. Now let's talk about how we can authorize users inside of our backend applications. In this example, let's say we have some HTTP server running in ECS. We can make a request, for example, get API v1 example, and we can then pass in the user's ID token as a header, which in this case is just named XUserJWT. It doesn't need to be in a header. It can be in a cookie or a query parameter, but this example puts it in a header since that's where it would typically go when making calls to backend services. Then, once the application receives a request with the ID token, it can make a call to NetID Login Service at the OIDC key set endpoint. That's step 2. This returns the public keys that are associated with the private keys that NetID Login Service uses to sign these ID tokens. Using the public keys, we can verify that the ID token hasn't been tampered with and that it's valid. And afterwards, we can check the body of the ID token to see if it's expired, along with any other user information such as email, name, NetID, manifest groups associated with the website domain, and more. While we have the AWS JWT Verify library listed here, you can use just about any JWT verifier that suits your needs. Additionally, I'd recommend caching the results from the NetID Login Service key set endpoint, as those most likely won't change. Now, if the public keys do change, then that just means that any non-expired tokens that were signed in before the change would be invalid anyways due to a key mismatch. This would invalidate any user sessions that are currently not expired, effectively making them not logged in. And there's not too much code that goes along with this either, and it allows us to determine without a doubt who exactly is making the request on a user level. So that just about wraps up the concept in this presentation. We've discussed all the cloud services needed to bring up a web application that should be protected behind NetID login, while still having as little architectural complexity as possible. After all, the simpler the better. For website distribution, we're able to use AWS CloudFront to regionally distribute our web application, whose files are stored inside of an S3 bucket. For the infrastructure, using Terraform allows you to plan your deployments so that you can have as predictable of a deployment as possible, with quick rollback if needed due to a deployment failure. Lastly, for user authentication, we're able to use the OpenID Connect standard by implementing the OAuth 2.0 flow inside of an AWS Lambda Edge function. This gives us maximum control over user logins and allows you to extend user identities to your backend services. This architecture concept has already been implemented in the new Degree Audit Reporting System, or DARS application for advisors and staff. Over time, we can continue to migrate web apps over to take advantage of all the benefits we gain by using OpenID Connect for user identities. So thank you for joining me this morning. We've now reached the Q&A section of the presentation. So if you have any questions, feel free to ask away.
For those who haven't seen in the chat, you've got a couple different options. Oh, we've got a first question here from James. Are there recommendations on configurations of manifest groups to help distribute easier across campus?
For recommendations, I don't necessarily have any, because for our applications, we kind of have specific user groups that we target. So we don't really have like general configurations in that manner. So not recommendations for us anyways.
All right. Jim Helwig has a question. How do the cloud costs compare to using Do-It shared hosting?
Yes, and I'll kind of answer the next question as well along with this. So managing cost and the cost of it, those costs are managed in the AWS Management Console, and you can access all the billing for all the services all in one place in AWS there. Now, as for cloud costs, I'll kind of give you a brief rundown of the stats. So CloudFront has a free tier of about 1 terabyte data out and 10 million requests per month with free SSL certificates or TLS certs. Afterwards, it's about 8.5 cents per 1 gigabyte or $85 per terabyte of data out to clients. And then about, let's see, $0.0075 per 10,000 requests, which is 75 cents per 1 million requests that come in. So that's kind of how they have the billing structured in AWS. However, what we do is we utilize cache control headers on our resources in S3 so that browsers will cache all the JavaScript, CSS, and any other assets. So each refresh will only fetch the index.html to see if the user's logged in. So this significantly lessens the data out and requests on the CloudFront distribution. Because for our Angular builds, when we build all the different chunks, I believe it's named like chunk and then the file hash, I think. And so when the user pulls that file, it's the hash of that file. So that means that there's just no changes to it. Now, when we deploy changes to our Angular app and the file names change, then the user won't have it cached. So it'll just pull it anyways. And then afterwards, it'll have it cached, so it won't pull it again, which saves on requests to the CloudFront distribution. So there's ways to reduce that cost as well.
We have another question from, and they say, thanks for the presentation, Ben. Could you talk about the costs associated with ODIC compared to SAML/AWS Cognito service?
So Cognito, one of the issues with Cognito that we ran into was, I believe the free tier was 35 or so users. And then after that, they priced off of monthly active users, which ramped up pretty quickly. Let me see. So price per monthly active user is $0.0055. So adding that up, I guess I'm not sure how much that would be, but it adds up pretty quickly when you have tens of thousands of users and you have to store them all in Cognito. So Cognito really adds up over time when you have more users. And then with OIDC, you're not necessarily storing user information. You're just doing the login flow, and then you're not really storing anything about them. So that pulls out that whole part of it. And with Cognito would need to connect with NetID Login Service too anyways. So it's kind of like these two parts playing together in your application. Whereas with just one Lambda to do the login flow with NetID Login Service, it's just that one kind of simple part instead of having to use Cognito for that as well.
Our next question. Did this configuration cut off a threat actor who is attempting to brute force the login or run a dictionary attack?
Let's see. Well, what we do after redirecting the user to login service, that I don't think I have the answer to that since we don't manage the NetID login service. So this is kind of like a separate part of that. So since we don't manage NetID login service, I don't have a good answer for that. But if the user is not logged in, we just redirect them there to log in. Other than that, I'm not sure on the internals of that.
Did anyone else have any other questions? If you'd like to say them out loud, please just raise your hand and we'll unmute you.
And yes, I was reading your comment, Andrew, that yeah, there's a lot of possibilities with this that we're kind of looking with, especially with the AWS SDK. Because normally when you're making calls to like a AWS service, you do that in a Lambda and then have the user make a request to the Lambda, and then the Lambda does that. But if you have like an admin portal, let's just say that example. If you have an admin portal where you have site administrators and a separate site for that, you could almost put the SDK right in the browser. I know it sounds crazy, but using these ID tokens is what would secure that. And then make all those calls in the front end without having to use Lambda, which kind of cuts off that as well, as crazy as it sounds. So there's really a lot of possibilities with this too when you have identities in a JWT that we can use not just in front ends, but in backend services too. And they're easy to verify too. So it really allows us to, without a doubt, verify who our users are, especially in backend services.
Well, that actually brings us to time. And I'd really like to thank Ben for a wonderful presentation and for everyone for attending. And we've actually worked it into the schedule that everyone has a 10-minute break to stretch your legs before the next session start. And I hope everyone really enjoyed this. Thank you.